Alright, let's go ahead and talk through this one. This little video is going to be on colligative property. Colligative properties, as you can see right here, they are the properties, and what we're going to care about are the melting and boiling points of solutions. Remember, a solution is a solute and a solvent. So our typical solution that we would talk about is salt water. Alright? So this solution of salt water boils at a higher temperature and melts and freezes at a lower temperature than the pure solid. That literally is all that you really need to know as far as the colligative property is concerned. Just the application of that, we actually use in the winter when we add salt to the snow so that it doesn't freeze. Okay? It freezes at a lower temperature, which means we can get about 8 or 9 to 10 degrees colder weather before ice will start to form on the road. Now, snow does not melt the ice. It just stops melted snow from freezing. All right? Willard Bay freezes in the winter. The Great Salt Lake doesn't. That's because of the change in the amount of salt in that water. Okay, now, a little bit more as far as we're concerned with solutions. Oftentimes they'll have a test question that looks a little bit like this. And I would guess this year they will, and if they do, it's going to be a drag and drop, where you are asked to drag solute particles like calcium chloride. Calcium is at 2, chlorine is a -1. It's an ionic substance, so it will dissolve. And when it breaks apart, this would be a picture that you could make for a low concentration. Notice you have calcium, and it's a +2, and there's 2 of them. And in the rest of the solution, there are 1, 2, 3, 4 chlorines. They could test you to make sure that you know that these break apart into 3 pieces. We'll talk about that more in a second. Then this would be an example of the high concentrated. There's calcium all over the place, and then there's chlorine all over the place. And it's always in a 2-to-1 ratio. All right. On the core test, there's also what we call dissolution reactions once in a while. And we don't really talk about these that much. They're very simple. It's not really a reaction, so it's a little bit tricky to say that. But this calcium chloride, all right, when added to water, will break apart into Ca plus 2 plus 2 Cl minus. That literally is all that we're talking about. We go from this solid to this, which is aqueous. Okay? So if the core test ever asks you to talk about a dissolution reaction, it's just saying that the ionic substance breaks apart into its ions in water. All right, I kind of got a little distracted. I forgot I had a different plan on that, but I remembered that's on the test. Now, if we look over here, this is a heating curve for water right over here. You can see that the black line represents where water freezes or melts, and that's at 0. All right, or where it boils or condenses, and that's at 100. So the black line represents water. The blue line represents salt water, and this illustrates its colligative properties. The blue line is melting or freezing underneath 0. All right, because we have lowered the melting and freezing point. Up here, the blue line goes above the black line because salt water, its colligative properties, say that it will boil at a higher temperature. All right, so a colligative property or a solution stays liquid longer. and I don't know if longer is the right word, but it stays a liquid over a greater range of temperature. All right, so that's your colligative properties. Hopefully that's a good review as far as solutions as well, the dissolution reactions. We'll call that good.